Welcome to Module 6, Pressure Control During Well Intervention. By the end of this module, you should be able to define some important terms used in pressure control during well interventions, identify what can go wrong during well intervention planning and operations, recall the first actions when a well control situation arises, describe the plugging and abandonment process, and recognize the key roles and responsibilities of those involved in the event of a primary barrier failing. Chapter 3. What can go wrong? Chapter 1. Introduction. When it comes to well control, the main difference between drilling operations and well intervention operations is that during drilling our objective is to never have pressure at surface. Well intervention operations are conducted on wells where pressure is always present at surface. As well interventions are routinely conducted on live wells, occasionally these operations can lead to complacency. Measures should be taken to prevent complacency. After all, we are still working with hydrocarbons, and so an unsafe release is possible. There must always be a system of barriers in place to prevent the accidental release of hydrocarbons and consequently the potential loss of life, damage to the environment, and the reputation of our industry. In this chapter, we will define those barriers and the circumstances that they are used in. As with drilling operations, in well intervention operations the main objective of a well barrier is to prevent any accidental release of hydrocarbons from the well to the environment. There must be at least two barriers in place during well intervention operations. The first level of protection is called a primary barrier. The second level of protections is called a secondary barrier. The primary barrier's function is to prevent unintentional flow to the environment. The secondary barrier is to prevent unintentional flow if the primary barrier fails. Let's look at an analogy to assist your understanding of primary and secondary barriers. If you were to consider a castle during an invasion by hostile hordes, the moat around the castle could be referred to as the primary barrier. The water acts as the first line of defense to outside intruders and helps prevent an invasion of the castle. If the hordes did manage to get across the moat, then they would be faced with high castle walls and the portcullis or gates. These could be classed as the secondary barrier. As you can imagine, the primary and secondary barriers together would have presented quite a formidable defense against invasion. In well control, the two barriers form what is called the barrier envelope, and this is the line of defense we have in a well-controlled situation. Well barriers are different for the drilling, production and well intervention phases, but in all cases they are there to prevent any accidental release of hydrocarbons from the well to the environment. For example, during drilling operations, the primary barrier is the hydrostatic pressure of the column of drilling fluid and the secondary barrier is the blowout preventer stack. During the production phase, the primary barrier is the production tree and the associated valves, and the secondary barrier would be the downhole safety valve. In the case of well intervention and workovers, instead of the production tree and associated valves forming the barriers, the BOPs and related equipment that comes with the workover and well intervention package form the barriers. Let's have a closer look at some of the barriers that are used during well intervention operations. Let's start with the primary barriers that are needed during well intervention. During coiled tubing operations, this would be the stripper rubbers and the double flapper check valves at the tip of the tubing. The second flapper acts as a backup in case the first flapper doesn't seal. During wireline operations, the primary barrier is the lubricator and stuffing box or grease head. During snubbing operations, the primary barrier will be any of the multiple BOPs that are an integral part of a well-controlled system when running tubulars in or out of a live well. Secondary barriers during well intervention operations are coiled tubing BOPs, wireline BOPs, and the lower BOPs of the snubbing stack. Chapter 2. Planning. Now let's look at the planning that takes place before a well intervention or workover operation begins. After all, it is essential to have procedures in place in case something goes wrong. The planning starts with looking at why the well needs a workover or well intervention, and includes the equipment and personnel needed to carry out the task. Prior to any well intervention or workover operation, there should be a formal handover. This handover must clearly identify the roles and responsibilities of all concerned. Planning considerations must also include how long has the completion been in place and what is the history of its service. For instance, has the well been producing sour gas? Is a well kill required before operations take place? Liaison and coordination with service companies and/or drilling and workover rig owners. What happens when things don't go according to plan? Is there a contingency plan if it goes badly wrong? Is there an emergency plan? Is extra role-specific training required for this particular operation? As with all operations, during a well intervention or workover, safety is of paramount importance and must be considered during every step of the planning phase. Risks should be assessed and contingency plans put in place to mitigate the consequences. Logistics issues should be planned between all parties. This will include helicopters, fuel, chemicals, supplies, etc. Throughout the operation, well control must be maintained. Therefore, at the planning stage, consideration must be given to all activities to be carried out and the equipment required, both at surface and downhole, including pressure and temperature rating of the equipment must be suitable for the environment in which it will be used. Pressure and function testing of equipment prior to any operations being carried out, including pressure control equipment such as blowout preventers, and fluid circulating equipment such as kill pumps. All additional materials such as kill fluid must also be available on site for the operations to be carried out. We are still not through the list. Consideration must also be given to plugs and tubulars, Christmas tree and tubular removal, and personnel roles and responsibilities. Once the plans have been finalized, they then have to be reviewed and approved by the appropriate authorities. Just from the few items covered here, it can be seen that a lot of work has to go into planning, and there are many people who will have an input. Of course, once approved, these plans have to be communicated to all who will be playing a part in the well intervention operation. Chapter 3. What can go wrong? Throughout any well intervention operation, there are many things that have the potential to cause issues. All risks will need to be assessed, and contingency plans must be put in place to mitigate them. Issues that may arise include failure of surface pressure control equipment, failure of downhole pressure control equipment, equipment or tool failures at surface or downhole, for example, wireline breaks or coiled tubing leaks, the BHA stuck across the wellhead and unable to shear in an emergency, and, possibly the most important, issues caused by human factors. Many of the well control situations which occur in well intervention operations can be attributed to failure of the primary mechanical barrier, although the well can normally be made safe by activation of the secondary mechanical barrier. Part of the contingency planning will have included remedial action to regain primary control. Let's look at this more closely. During coiled tubing operations, the primary barriers would be the stripper rubber on the annulus side, and the surface and subsurface check valves on the tubing side. Should the stripper rubber leak, operations should stop and the pipe rams closed. Should one of the check valves fail, there is normally a backup, but as a last resort, the tubing can be sheared and the blind rams used to seal the well. In workover operations, with the well killed, the primary barrier is normally the hydrostatic pressure of the fluid in the well, as in drilling operations. Should this hydrostatic barrier fail, the secondary barrier, the BOPs, would be activated. As mentioned in Module 4, human factors also have the potential to cause issues. As a reminder, human factors refer to the interaction of individuals with each other, with facilities and equipment, and with management systems. As with drilling operations, in well interventions and workovers, human factors play a critical role in ensuring that pressure control is maintained. It is a broad subject, but non-technical skills, i.e. the cognitive, social and personal resource skills that complement technical skills and contribute to safe and efficient task performance, can be considered under the following titles: situation awareness, decision-making, communication, teamwork, leadership, and managing stress and fatigue. Let's look at how human factors could potentially cause issues during well intervention operations. During a wireline fishing operation, when the fishing assembly was recovered to surface, it was discovered that the tool string plus the fish was longer than the lubricator. The crew made a decision to pump what they thought was enough fluid to kill the well. Then they rigged the lubricator down and removed the tool string without ensuring the well was dead and the correct barriers were in place. This could have led to a major incident. Chapter 4. First Actions. During a pressure control situation, everyone should know what to do from the mechanical point of view, as they are trained and competent in their job role. With that being said, in this chapter we'll look at first actions with regards to how the crew members themselves react within the team, rather than the technical procedures that should be carried out. Positive behavioral first actions in a pressure control situation could include actively seeking and working to understand all relevant information, recognizing situations where a timely decision is needed, recognizing the importance of good communication with team members, conveying information at the right time succinctly and clearly, listening effectively, implementing decisions, collaborating with and supporting other team members, adopting suitable leadership styles and practices, and providing feedback, motivation, and support. Communication is an essential part of safe well operations, or process safety, and the following points should be made clear and be understood by all personnel. The consequence of barrier failure and unintentional flows to the environment or to other formations. Which components in a well are the primary and secondary barriers during specific work on the well? That the specification of the components is suitable for the intended use. That the test, examination and installation process for these components is understood. And that the function and pressure test acceptance criteria relating to each component is available at the location. Chapter 5. Plug and abandon. There are 3 scenarios where a well would be plugged and abandoned, and they all have one thing in common. The cement plugs must comply with regulatory standards and specifications. 1. If an exploration well is dry, which means there is no significant show of hydrocarbons, then it will be plugged and abandoned with a view to it never being re-entered. 2. Some wells are temporarily plugged and abandoned if the well control equipment, such as the BOP, is removed and the intention is to resume well operations at a later date. 3. Wells are also plugged and abandoned if they have been producing for a significant amount of time but are no longer commercially viable. In most cases, a minimum of 3 cement plugs will be set in the well, but this may vary depending on local regulations. Note that it is just as important to monitor the well barriers during plug and abandonment as any other phase of the well's life cycle. During plug and abandon operations, cement is placed in the wellbore to form a solid plug that will not allow formation fluids to flow between different zones or to the surface. The cement plug must provide a lasting seal under any conditions that may exist in the well for an indefinite period of time. The slurry for cement plugs is made up of dry cement, water, and various additives to give a recipe that ensures that the plug does the job it is designed for. The recipe has to take into account the formations it will come into contact with, the pressure in the well, the temperature of the well, the depth of the well, and the volume of cement to be placed in the wellbore. So, how do we set the cement plug? 1. Firstly, the kill fluid is conditioned to ensure that the weight of the fluid is consistent throughout the well. 2. The correct volume of cement is pumped down the drill pipe. 3. Once the cement is inside the drill pipe, it is followed by kill fluid until there is an equal height of cement inside and outside. This is called a balanced plug. 4. The drill pipe is then pulled out slowly, leaving the cement plug in the correct place and at the correct height. In the cased hole section, a packer may be set to support the weight of the cement until it sets and further reinforce the barrier. These procedures will be carried out for all cement plugs. After sufficient time has been allowed for the cement plug to set, it must be pressure tested to check integrity and checked that it is set at the correct height. This is usually done by tagging the cement, measuring where the top of the cement is, probably using the same tubing that the cement was pumped through. Chapter 6. Roles, Responsibilities, and Empowerment. In Module 4, we found out that those involved in drilling operations each have their own roles and responsibilities, and the same applies for those involved in well intervention and workovers. In the event of any suspicion that primary well control has failed, some personnel have the role of observing, monitoring, and informing. In well intervention, this will include assistant operators. The next level of personnel have the responsibility, the empowerment, and the duty to act to make the well safe in the event of loss of primary control. It is likely that this action would be closure of the blowout preventers, and this would be performed by the equipment operator. Next are the well service supervisors, either single or multidiscipline. Persons in these roles are expected to analyze the situation, plan and carry out the actions required to regain primary control. The actual responsibilities of each person may vary depending upon specific company requirements. However, their roles must be clearly defined before any work takes place. Well intervention is slightly different from drilling where empowerment is concerned. Of course, everybody should be working in an environment where the obligation to do the right thing is known, authorized, and expected. But some companies that supply well intervention services may be working on a different well site every day, and will therefore be working by a different set of rules and regulations on a regular basis. With this in mind, it is imperative that well intervention workers attend a site induction, and these personnel must be made aware of their obligations and be assured that there will be no recriminations for making what they believe to be the right call. This applies to the equipment supervisor through to the crane operator or truck driver that may be on site for only a few hours. Despite not being full-time workers on the well, intervention staff must take ownership during their operations, no matter how small, and be empowered to do the right thing at all times. Well done, you've reached the end of this module. You should now be able to define some important terms used in pressure control during well interventions, identify what can go wrong during well intervention planning and operations, recall the first actions when a well control situation arises, describe the plugging and abandonment process, and recognize the key roles and responsibilities of those involved in the event of a primary barrier failing. Thank you for completing this training module. We hope this will help you in your workplace. Remember, you can revisit this module at any time to refresh your knowledge.